next oxide of nitrogen being nitrogen 2 oxide. Nitrogen 2 oxide written as NO, nitrogen valency 2, oxygen valency 2, they cancel out to form NO. So how is nitrogen 2 oxide prepared? Nitrogen 2 oxide is prepared by using two reactants mainly. The first one is copper turnings, and the second one is dilute nitric 5 acid. Dilute nitric 5 acid being about 50% nitric 5 acid and 50% water. So dilute nitric 5 acid will react with copper turnings to form copper nitrate, nitrogen 2 oxide and water. Now this is the setup. Copper reacts with HNO3 aqueous because it's dilute to form copper 2 nitrate plus NO plus water. Setup being, this is a Thistle funnel, it has no tap. Copper turnings here, the dilute nitric 5 acid just flows into it. This is all nitric 5 acid, nice little nitric 5 acid, reacts with the copper turnings to form copper nitrate. The gas produced, which is collected over water method, is nitrogen 2 oxide. Over water means either it is insoluble in water or slightly soluble in water, but here we will say it is insoluble in water. Now, a good question asked and favorable for examiners is, why are there brown fumes produced in the conical flask? In this conical flask, brown fumes are formed in the conical flask. Why? This is because, as we know, before there is anything in this flask, there is air, and when there is air, it means there is oxygen. So the air, the oxygen that is already there, oxidizes the NO, the nitrogen 2 oxide, to form nitrogen 4 oxide. Okay, so the oxygen already present in the conical flask will oxidize nitrogen 2 oxide to form nitrogen 4 oxide. Nitrogen 4 oxide being brown, that is why the observation will be brown fumes are formed. Here is the overall equation: nitrogen 2 oxide plus oxygen to form nitrogen 4 oxide. The physical property is the gas is a neutral gas. It has no effect on litmus paper. It is neither acidic nor basic, just neutral. The uses of nitrogen 2 oxide, just one use. It is used in the manufacture of nitric acid. I think it's called the Ostrow's process, maybe. So nitrogen 2 oxide is an oxidizing agent, as we saw previously for nitrogen 1 oxide. It is an oxidizing agent. However, it is slightly more stable and it is difficult to decompose. So it will oxidize, but at a slower rate. Okay. So you can check the oxidizing reactions we wrote in nitrogen 1 oxide, but an example just to repeat is magnesium reacts with nitrogen 2 oxide. The nitrogen 2 oxide, the reaction being exothermic, breaks the nitrogen 2 oxide into nitrogen and oxygen. The oxygen produced is used to support the combustion. So a white solid of magnesium oxide will be formed. Why? Because of instability. Yes, it is slightly stable than nitrogen 1 oxide, but it is still not completely stable. So it can be broken down. So when the NO is broken down into nitrogen and oxygen, the oxygen is used to support combustion and nitrogen gas produced as a byproduct. Okay. Nitrogen 2 oxide reacts with sparked hydrogen, forming water and nitrogen gas. Now, why is the hydrogen sparked? To provide the activation energy. What is activation energy? Activation energy is the minimum energy required to start a reaction. So the reaction cannot start just like that. You need a spark to give the activation energy to start the reaction. So without the spark, the reaction cannot start. So nitrogen 2 oxide reacts with hydrogen to give water and nitrogen gas. Now, the last thing about nitrogen 2 oxide we need to know is the test for nitrogen 2 oxide. What is the test for nitrogen 2 oxide? You bubble nitrogen 2 oxide through a solution of freshly prepared iron 2 sulfate. When you bubble it through a solution of freshly prepared iron 2 sulfate, a brown ring is formed. This is the general test for nitrates. A brown ring is formed. Why is the brown ring formed? Now, what is the substance that is causing the brown ring to form? It is called nitroso iron 2 sulfate. You don't need to know the formula, but you just need to know in words it is called nitroso iron 2 sulfate. So when the gas is bubbled through freshly prepared iron 2 sulfate, a brown ring is formed, and O nitrogen 2 oxide dissolves in iron 2 sulfate to form a brown solution of nitroso iron 2 sulfate. That's it about nitrogen 2 oxide. Now in our next session we will cover nitrogen 4 oxide. Stay tuned. Thank you for watching.